is going to start talking about proving that triangles are, what's the word here? Congruence, showing that they are the same triangle by, okay.
SAS.
We're going to get a little sassy today, all right?
Yes.
Or saucy, whatever you want to call it. SAS. SAS. Anybody have a guess what SAS stands for?
Angles.
Triangles have what? Angles and sides, right? So what do you think SAS stands for?
Sides. Angle.
Side, angle, side. Some of you are probably thinking, oh my gosh, SOS, please help me right now. But it's SAS today, all right? Side, angle, side. Yeah, this is what this stands for. We're going to show today that triangles are congruent by what's called a side, angle, side proof. Okay? So our question today is this. It says, what can you conclude about two triangles when you know that the two pairs of corresponding sides and the corresponding included angles are congruent? Okay? So, right here, guys, it says use the side angle side congruence theorem to be able to answer this question. And then we're going to look at some real life situations that would involve this. And honestly, this section is pretty gosh darn short today. Okay, pretty darn short. Here's what side angle side says about triangles. This core concept really is our big idea today. Okay, there's the big idea, core concept. It says if two sides and an included angle, if two sides and the included angle of one triangle are congruent to two sides and the included angle of the second triangle, then the two triangles are what? Congruent. Okay? Now guys, what they're getting at is this. I've labeled this triangle up for you. Can you guys help me with my vertices on the first and second triangle?
Yeah, first one.
Okay, at the very top of the first one. A.
B. And C.
Okay?
And then, do you want the tick marks for that one?
Not yet. Give me the vertices on the second.
That bottom one is Z. Y. X.
Okay, over here, tick marks on the bottom at all?
There's one.
One, and I'm assuming two on the left or right.
Two on the left.
And there's an arc mark at C.
Yep.
Okay, and then
Arc mark at X.
arc mark at X. Tick mark.
Yep.
Double mark.
Yep.
Okay. Here's what they're talking about, guys. In this right here, they give you some information about these two triangles. Okay? Basically what they've shown is the following. How many sides, or I should say, how many pairs of sides have they shown congruent between the two triangles? Two of them. They've used the tick marks to do that. Second question is, how many pairs of angles have they shown congruent? Just one pair, C and X, right? Okay. Well, guys, side angle side says this. It says if you have two sides of a triangle, let me write this up. I'm going to kind of highlight this here. It says if you have two sides of a triangle, for instance, this side and this side that you know the lengths of, and then this side and this side that you know the lengths of, like that, do you agree that the two sides with the tick marks form an angle? Is the angle in between the two sides or not in between the two sides? In between the two sides. So what they're getting at is this. If you have two sides, and the two sides that form the angle there with those two sides, if you have all that stuff congruent, then it says by side angle side, those two triangles will be, what's the word I'm looking for? Congruent. Okay, these two triangles will be congruent. Okay, this is what I'm going to tell you. You might want to write this down there. These are congruent because here I have a side corresponding to a side. They're equal in length. Do you agree with that? And if I would start right here on this yellow line, I go from a side, then I turn the corner. And turning that corner is like my, and when I say this furthermore, I'm talking about the, what's the word I underlined right here, or phrase? Included angle. That's a big, big piece of that theorem right there. Okay? That's a big, big piece of that theorem. Guys, why isn't angle A the included angle? Why is it angle C down here?
Because it has an arc mark.
It has an arc mark, But is it between, is this angle between the two sides that we know the length of? No. This angle has to be between the two tick marks, if you will, or the two sides that you know are congruent. Does that make sense? So if I would follow this yellow path, we start on a side, we turn a corner at an angle right here, which I'll abbreviate with A and G, angle. And then we turn the corner and we're back on another what?
Side.
And that line is a side right here. So it kind of goes side, angle, side for that route. And that angle has to be the corner of the two adjacent sides that you're talking about. Okay? So here, don't you go side and then turn a corner, have an adjacent, or I'm sorry, a corresponding angle that's congruent right here. Don't you turn a corner at an angle? And is that angle included between the sides that have tick marks? Yes. It is. Okay? So hence the name, side, angle, side of this theorem. All right? So again, core concept, real quickly. Hang on one second, John. It says if two sides and the, what's the phrase again that I'm underlining right up here? Included angle of one triangle are congruent to two sides and the included angle of another triangle, then gosh darn it, those two triangles are congruent. You bet. Okay, John, what was your question, bud?
What is that thing up there say below the second triangle?
Below the second triangle right here.
No.
There.
Below the words, second triangle up there. With that arrow pointing to the
This here.
Yeah.
ANG, it's just short for angle. That's the angle measure that we knew. That's the included angle between the two sides. Or that's the angle formed by the two sides that you're talking about. Good with that?
Yep, I'm good.
All right. Guys, quick review on some vocabulary here before we look at some examples. First things first, congruent figures. We already know congruent figures are figures that what? Same size and shape. These two are congruent up here because they're the same size and shape. The way we're going to show stuff is congruent today now is by using this triangle theorem, which is abbreviated side, angle, side. We're going to show these for side, angle, side. Then, we already know what rigid motion is. It's a transformation that maps one figure onto another congruent figure. Take a look at this right up here, guys. If I write this up as triangle ABC, that first one, we know they're congruent by side, angle, side. Give me the order on the second one with how you name it. Where does A fall? Where does B fall? Where does C fall? By the way, I set that first one up. Where would A fall? Y. Where would B fall? Z. And where would C fall? C would fall on X. So what's the order have to look like here for my triangle congruency here? Say it one more time. Y is the X. Okay. So the core concept, or the big idea today that we're discussing is we can show that triangles are the same triangle by what theorem? What congruency? Side, angle, side. Understanding that that angle that we're talking about is the angle included or between the two sides that we are pairing up. Cool with that? Okay. More time on this at all? Yay or nay?
No. I do though.
Good. Need some more of this. Good?
Yep.
Let's rock here. Guys, if there's an important example in the notes right here, or a most important example in the notes, this is it. Okay? Big time important. Right here. Okay? Big time important right here. Example 1. Very important. You might want to highlight it, do what you need to do. All right? You automatically aren't going to like this right off the bat because the first thing it says after example 1 is do what? Write a proof. Yay! Anna, settle down.
Not gay.
All right. It says right here, you're going to have to help me on this. I believe B is right here. Is that right? A is here. D is here. Makes this C. And I believe there's right angles down here. Okay. There are some things that we are going to have to recall from a while ago. They may be locked in your long-term memory. We might have to dig and find that up a little, all right?
I don't really have one.
I don't either, okay? My long-term memory is just choose to forget. It's kind of like my email. Delete, gone. All right, here we go. Huh? What? I missed it. Bryce?
Not Hillary's.
Are you dissing on my choice for president right now?
Yeah.
Well,
Trump 2016.
Wilson, I don't even have a comeback for that because that was actually pretty good.
That was really good.
Oh, man. All right, Parker, you're up 1-0 today. I'm going to leave it at that, okay? That's what I'm going to leave it at. So, all right, no problem. No problem. I get it. I get it. We all make mistakes. Some are just bigger than others, right?
A little bit.
All right, well, let's find our focus on this thing right here, okay? Let's find our focus on this. First thing it says in the following, it says, we know that B is what?
Point.
Midpoint of AD. So if I have something that's 10 units long, a midpoint is going to take that and divide that into two segments that are how long? 5. 5 on the left, 5 on the right. We all agree with that?
Yep.
So if B is the midpoint right down here, what's that going to say about this segment from, let's say, A to B right here? And that segment B to D. What's going to be true about those? They're going to be the same because B cuts AD into two congruent segments. That's a definition of a what? Midpoint. So here's how we're going to start this, guys. If you guys can recall this, anytime we try to prove something, we always make this little T-chart. Okay? So let's roll on this. We have always said that anytime you start with a proof, you always write down what as your step 1? Write down the stuff that is given, right? Ryan, question?
I was asking.
Sure can. All right. What's given to us then, guys?
B is the midpoint of AD.
B is midpoint of, what'd you say, AD? Segment AD?
AD.
Okay, that's given to you. What else is given to you?
Angle ABC and
Okay.
DBC already.
All right, so I'm going to write this down as well. Angle ABC and angle DBC are right angles, right? And that is also what?
Given.
That's given to us. Okay, so what's the core concept today? Proof triangles are congruent by SAS, which stands for
Side.
we want corresponding side included angle corresponding side to match two triangles to show that these are congruent. That's what we want. So let's roll with this right here. Guys, since B is my midpoint of AD, and you told me B divides a longer segment into two equal segments, which two segments at the bottom of that big triangle are going to be equal now for step number 3? Okay, so I'm going to say the following. AB is congruent to what? AB is going to be congruent to what now? BD, and that's by definition of a midpoint. Excellent. Definition of a midpoint. Hey, what's good here, guys, is this. When I write step 3 saying AB is equal to BD, what part of that side angle side congruence theorem have you already satisfied? You've satisfied a side. Okay. Oh, I have another question. They gave you this. Angle ABC and DBC are what? Right angles. So we know that they are what? They're congruent as well, right? Isn't that given to you? those angles are already congruent. So I'm going to say that those angles are congruent. Definition of, I don't know, what do you want to call it? Right angles? That okay? Okay. Or I could just probably leave it like this in step 2 and say, oh, that's probably good enough. Okay? So I think what I'm going to do is this. What I'm going to do with this in step 4 is the following. Step 4, we know the angle is 90 degrees right here, right? I'm going to write this for step 4. Angle ABD is equal to angle, how about, whoops, I got that wrong. ABC is what I meant, right? You guys see angle ABC right here, guys? Okay. It's going to be congruent to angle DBC. Reason is they are both 90 degrees. They both equal 90 degrees. So that's like saying, hey, if one angle is equal to 90 degrees and the other angle is equal to 90 degrees, they're equal to each other by which property is that? You remember? Start with a T. Say it again, Bryce. Transitive, yeah. Both are 90 degrees. So that's just saying this is really the transitive property. Okay. This right up here in the given says ABC is 90 or a right angle. DBC is a right angle. So if they're both right angles, they must be what, guys? They must be what? Must be congruent, right? Hey, step 3 we satisfied a side. Step 4 we satisfied an angle. What else do you need to satisfy? Is there any way that you can show that there's a pair of sides in each triangle that are equal from here on out? Take a look at your diagram. Isn't this side part of both triangles right here in the middle? Couldn't I say BC is equal to BC because it's the same darn line?
Yep.
Okay. So I'm going to say this right here. I'm going to say in part 5, segment BC is congruent to itself, segment BC. And that's just going to be considered what's called the, if you have one thing and it's called the same thing, that's called the, anybody remember it if it starts with an R? Reflexive. Okay. Guys, this satisfies a what, guys? An angle or a side congruent. So by steps 3, 4, and 5, what can you conclude now about your two triangles? You've shown two pairs. You've shown two pairs of sides congruent. The angle that you have is between the two sides. So number 6 right here, and guys, your last step every single time is always going to be these triangles are congruent by what? Congruence theorem. You're just simply going to say, here's my proof. Triangle ABC is congruent to triangle what up here, guys? And what's your reasoning? SAS. Side angle side. Find a way to show that sides are equal. Find a way to show that some kind of included angle is equal. Once you've done that, just like SAS, you are DUN done. Does that make me DUM done?
Yes. Wow, okay, you're just a dummy guy.
Boom, I'm glad I haven't given the assignment out yet. Alright? What do you think about that? Oh, now she's just kidding. That's right, she didn't say JK. JK, LOL. Alright, let's roll. Let's roll. Look, guys, refer to this. Refer to this, refer to this, refer to this today, because I'm going to tell you what. This idea of proving triangles congruent by side angle side, there's going to be a lot of patterns that are almost repeated just like this. Okay? Now what I like about this section is not everything is a proof. They kind of just ask you the question, could you use side angle side on this? They kind of turn it into a yes, no type of thing. So minimal proofs, but understand that proof so that you can apply it to know if triangles are congruent or not. Make sense to you?
Yeah.
Okay. Questions on example 1 at all before I move? How many feel pretty good about this? Make sure you have this. Do you all have this right now? Okay. Let's roll on 2. Okay. Example 2 says, use your side angle side congruence theorem and properties of shapes. So it says, what can you conclude about, help me out please guys, up top here is S, P as in Parson, best letter in the alphabet,
No.
Q,
R.
must mean T is at the center. Please help me with my marks here.
S and Q have 2.
So S to T is too long. All right, so that's what you have in the diagram. Is that correct? Okay, so the question becomes, what can you conclude about triangle PTS? Let me highlight PTS. This triangle, boom, boom, boom. And what else? RTQ.
Hey, it makes one of those things. Yeah.
Looks like a kite.
What can you conclude about the 2 triangles highlighted in yellow right now? Why are they congruent? They have the ticky mark things.
Because two of the same triangles.
Okay, so we've got 2 pairs. We've got 2 pairs of congruent sides, right? That's good for side angle side. What about the angle though part? Have what again? Vertical angles. Here and here, right? Or inside. Yeah, these are intersecting lines, so that makes this angle right here equal to this angle. Guys, by the 2 sides that are tick marked out, or ticked out if you will, do I have an included angle between the 2 ticked sides?
Yeah.
I do. So do I have the right angle that we need to be able to apply side angle side here? You bet we do. That angle is sandwiched between the 2 sides with the marks that we know for congruency. So, what can you conclude about triangle PTS and triangle RTQ? You can say triangle PTS is congruent to triangle what? RTQ by which congruence theorem?
SAS.
By a little bit of SAS.
That's all.
That's all. They gave you the sides, didn't they?
Yep, they did.
And we know enough about intersecting lines to know, hey, if you have intersecting lines, vertical angles are going to be congruent. So you should be good to go here, right?
Yep.
Okay, do you understand this side angle side idea? That's my question.
Yes.
Okay, so let's get this last example done. I'm going to throw a few problems at you on a quick quiz here and get you going on this new assignment here in a second. Anybody need more time? Page 2. All right. In the words of Paul Harvey, page 3. The wings of a paper airplane have 2 congruent sides and 2 congruent angles. Use side angle side congruence theorem to show that IPA is congruent to IPR. Help me out here again. IPA. So I is up here, right?
Yep.
P is down here.
C.
A is on left.
A's on left. R's on. Yeah, R's on right. Person, who's Paul Harvey?
Except the I.
You guys don't know who Paul Harvey is?
I don't.
Mrs. Olson, a little faster claim, you think? Anybody know what Paul Harvey would say at the end of his broadcast?
That's all,
Don't
folks.
even know who it is.
Mrs. Olson, say it.
I'll look it up.
Good day.
He doesn't
See?
remember.
Oh,
Hey, right here, I forgot to put something in here. I believe you have the tick marks up here already, is that right? I'm sorry, the arc marks up top.
Aardvark.
Arc marks, right? I forgot to put a tick mark here on the left and here on the right. Okay? Okay, what are we trying to prove, guys? Triangle on the left congruent to the triangle on what?
right.
Right. Well, here's the dealio.
IPA.
Here's the dealio. Let's just roll with this right here. Step 1's always going to be your what? Given. Now, they didn't specifically state what was given in this problem. However, can you look at the diagram and say, oh, I know that because they gave me that information. Can I look at that? What's the first thing we know? Let's talk about the side angle side. You need to show a side is equal to a side, an angle equal to an angle, and a different side equal to another side. Can I show side and side that are congruent at all? How? AI is congruent to what? AI is congruent to RI, right? Okay, what's the reason for that, guys? We had said in the last section, they give you the tick marks. They give you the tick marks, so it's really given to you, right? It's given. It's given. It's given. All right, how about this angle up here? AIP, what's that congruent to? AIP is congruent to RIP, which is what a lot of you would like me to do with this section right now. Let it. All right, let's do it. Yeah, angle AIP, angle APE, is congruent to angle RIP. Guys, we know that because of the arc marks. Did the arc marks just show up, or were they given?
Rest in
They
peace.
were given to you, right?
Rest in peace, Carson.
I'll try.
Okay.
Hey, the first one right here, that first given was kind of like the side part of the congruence theorem, wasn't it? That second step right here was like the, included angle part. So far, guys, we have a side and a side. We get to an angle, we turn the corner. We're turning the corner at this angle. Where are we running down to now? Which side? I to what? I to P, isn't it? Okay. Isn't IP part of both triangles?
Yeah.
Isn't IP going to be the same length if it's the same line for both triangles?
Yeah.
If IP is part of both triangles, doesn't IP equal IP?
Yeah.
IP.
What?
This has gotten out of control today.
IP, really?
Whoops.
Rowdy in here.
It is. I kind of like it though.
Did someone say IP?
Yep, I said segment IP. Okay, it's congruent to segment IP.
Okay,
Because they are the same exact
just FP
line.
on different.
That is going to be a reflexive property thing again. If it's the same exact line, it's a reflexive property thing.
Okay, we're on number 3.
Guys, that's like the side part to this right here. That's like the side part to this right here. So guys, have I shown two pairs of sides congruent? First question. Have I shown the included angle
Yes.
congruent? So if I've done that, then what can I say about the two triangles that we're trying to prove congruent?
IPA is
Run with it, Bryce. Say it again.
IPA is congruent to IPR.
Triangle IPA.
IPA.
Exactly. Congruent to
IPR.
triangle IPR. Because
SAS.
side, angle, side. There it is. Once you've shown two pairs of sides congruent and the included angle congruent, your last step is the proof. And it's done by side, angle, side. Okay? Kids, what questions? I'm going to make a deal. I'm going to hold off on the quick quiz today. I'm just going to send out a book page to get you started on this. But I won't be doing until Tuesday. Don't forget, when's 12.2 technically due for you? Monday. Okay. Monday when you get in here, we're probably looking at some time to work on this stuff. So don't forget, one more time. Test retake by what day?